Closures is the most important topic for JavaScript interviews, and there can be literally hundreds of questions that can be made on it. That's why after hundreds of years of research, I have curated some of the most asked interview questions on closure for this video. Just kidding, I haven't researched for that long, but it's gonna be good. So a closure is a function that references variables in the outer scope from its inner scope. To understand the concept of closures, you need to know how the lexical scoping works first. So I've opened VS Code over here with basic HTML, CSS and JavaScript files. So what is lexical scope? So a scope refers to the current context of your code. It can be either globally or locally defined. And with the ES6 version of JavaScript, we also have the block scope as we discussed in our var.let const video. So let's see. So since we have a variable right over here, this variable, this is in the global scope, right? But what if we go on and create a function over here? Let's call it local. And so this right here is the local scope. And this is the global scope. But what exactly is the lexical scope? So a lexical scope in JavaScript means that a variable defined outside a function can be accessible inside of another function defined after a variable declaration. But the opposite is not true. The variable defined inside the function will not be accessible outside that function. So let's see an example. So if I console log this name over here, let's call it username. Yeah. So let's go on and run this. Here's a browser. Let's go to inspect. Oops, we are not calling this function anymore right now. So yeah, now let's see. Yep, you see we get this output roadside coder over here because the variable defined outside of this function can be accessible inside of this function. This is called lexical scope. But what if we do this? If we take this line and put it over here and try to take this console log outside of this function, will this still work? Let's see. No, this is gonna give us the error. Username is not defined. So we cannot access the variables from inside of the function. We can only access the variables that are outside of this local scope. So you're watching this interview video maybe because you're having an upcoming interview or you're preparing for interviews to start applying to companies. But do you have proper guidance and hands-on experience to go about it? I guess not. That's why I'm about to tell you something that will accelerate your career. All you need to do is be ready to learn, practice, and work hard. AccioJob, founded by 4 IIT Delhi alumni, is a company that trains graduates and final year students in a 6-month full stack development course and gets them placed in a software developer role. The best part is, AccioJob take fees once students start receiving their salary, and that too if a student gets a CTC of more than 5 lakhs per annum. That means students get a 100% job guarantee. So far, the highest CTC that the student has got is 41 lakhs per annum, and the average CTC is around 8.3 lakhs per annum. More importantly, they have the minimum fees and payback period when compared to any other pay after placement program. And the most fantastic news for female software engineering aspirants is that AccioJob will bear 25,000 rupees for any girl who joins their program. So what are you waiting for? Apply now for free by clicking the link to the AccioJob website given in the description below. Okay, so let's see another example over here. So we have this function subscribe over here, which we are calling after it. And we have another function display name, which we are calling inside of this function. So you see we have multiple scopes over here. So let's call it inner scope. We'll call it inner scope 2. And then there is this global scope, right? So we have 3 scopes over here. So what's gonna happen is when we call this subscribe function over here, it's gonna initialize this function with this name roadside coder. And when we go inside of this function, this will be still accessible inside of this function because it's outside of this local scope, right? So we will be able to print this name. So let's see. Yep, you see, it's printed over here. So this thing exactly right here is what a closure is. The display name is called a closure. I know you might be a little confused right now, but let's go on and understand closures in depth. Also, if you would like to get in-depth knowledge about JavaScript functions, you can go and check out my previous video, which was completely on functions, where we discussed all of the interview questions related to the functions in JavaScript. Alright, so let's go to the Google and search closures. And we get this MDN docs over here. And according to this documentation, a closure is a combination of a function bundled together with references to its surrounding state or the lexical environment that we just discussed. In other words, a closure gives you the access to an outer function scope from an inner function. So as we saw in this code, that this function was able to access the variable outside of this scope. So this is what a closure exactly is. In JavaScript, closures are created every time a function is created. So you can see right here, this is the example that we discussed. So if we scroll further down, they've given us another example. So let me just copy this up and paste it right here. So what's going on over here? Let's see. Instead of this alert, I'm just gonna put console log over here. Yeah, so here we have defined this local variable name. And inside this, we have this function, inner function called display name. And we are returning this display name over here. So what we're doing is we are calling this make function over here and we're taking whatever that it's returning us. So it is returning us the display name. So now this gives us a function which we can call anytime we want. This is the inner function of this make function. So we can go on and call this and it's gonna execute this function right here and it's still going to access its outer variable of Mozilla. So if you go to the browser and see, yep, you see Mozilla is printed right here. And in some of the language, you wouldn't see this type of code working. But in JavaScript, this works. In JavaScript, every time we create a new function, it binds itself to its environment or its lexical scope. So it doesn't matter if you call this one directly over here or if you return it from this function, it's still going to have the access to its parent scope of this or let's say global scope. So it's still going to have the access to the lexical scope of its parents. So you must be thinking, what's the use of this syntax? So closures makes it possible for a function to have private variables. JavaScript closure is used to control what is and isn't in the scope of a particular function, along with which variables are shared between sibling functions in the same containing scope. So if I create another function right here with some another name and return that one as well, so that will also have the access to the scope of this function. So actually we will discuss all of these questions and concepts as we move forward in this video. I just want to make sure that your basics are cleared at this moment first. So we're gonna start one by one. Also, if you want to call this function display name, we can also do this. So let me remove this up. We're calling this function, and inside of this, since this returns us another function, we can do this right over here. So this returns us the display name, and then we are calling the display name right over here, just like that. So actually we can pass anything inside of here as well. So let's see first this works or not. Yep, this works as expected. So let me pass number 5 over here, and let's receive num, and I'm gonna print num. So yep, you see number 5 is also printed over here. So this just works just like a normal function, but we have much more power because of this JavaScript closures on our scope. Okay, so that were the basics of closures, but you might have heard of this term called closure scope chain. Let's see, let's go to the documentation again and see what this thing is. So right here. So according to this, every closure has 3 scopes as we already discussed. A local scope, that is this one, the outer function scope, that is this one, the outer function scope, and then the global scope. So it has 3 scopes right here. So a lot of people think that, okay, this function will only have the access to its outer scope and not the scope of the parent. What scope chain means is it's going to have the access to its outer scope as well and the scope of its parent. So if I go on and say where user name and give it a value and use this right over here, then you're gonna see we still get the output because it has the access to all of the scopes of its parent scope and the scope of its parent's parent. So this is what a scope chain is. Let's see what example they've given us to explain it. So as you can see right here, they have given us this example with a lot of local scopes in here. So let's paste it. Okay, so as you can see, we have this function here, and then we have another function nested, then we have another function nested, and we have this sum at the top. So we're calling this sum with 1, right? So it's gonna give this a 1. And then another inside of this, we have another function returned. Okay, so this will return b. Now we're supposed to call b over here. So then we are calling b with this parenthesis, and we're supplying the value of 2 to b. Also, sorry, the name of function is not b, the name of parameter is b. The function is an anonymous function. Right, so after that it's returning us another anonymous function. This will be returned over here. So now we're gonna call it again with value 3. So it's gonna have 3, and so on. It's gonna return another function, so we're calling it with this function 4. And now notice what happens. Inside of it we're returning a, b, c, d, e. So this function right here will have the access to all of the scopes outside of it. So scope where we have C value, B value, A value, and the global scope where we have E value. So it's gonna be able to access all of them, and it's going to log us 20. So let's find out. Yep, just like that. So this is what a closure scope chain is all about. Now they've given a bunch of more examples. I would highly recommend you to go and read more about closure and closure scope chain from this documentation. It's gonna really help you become good in this topic. Okay, so let's go on and discuss some of the most asked interview questions on closures. We're gonna start from the very basics and go to the advanced level questions. So as you can see right here, we're given a variable let count equals 0. And after that we have an ify over here. So if you don't know about what an ify is, you can go and watch our previous video on functions. There I've explained what an ify is. And right, so we have a function over here called print count, and inside this we have this conditional, and we're supposed to tell that what this will console log and what this will console log. So okay, we have count equals 0, so obviously it's gonna take count equals 0 inside this function, as we learned up until this video, because of its lexical environment or lexical scope. But we have a problem over here. We have another count equals 1 over here. Well, this is confusing. What will we print inside of this count then? Will we print count equals 1 or count equals 0? Okay, so let's see. So this is checking if count is equals to 0, which yep, it at this point it is 0. So we're gonna go inside of this. Then we're saying that let count equals 1. Now this concept right here, this is called shadowing. And I've explained this concept in our var let const video, that this is a block scope right here. And this variable is going to shadow this variable from outside. So this is going to overlap the value of count with 1, and it's going to print 1 over here. But outside of this, keep in mind this is inside of this block only. It's not going to affect the environment outside of it. So outside of it, count is still 0. So count is still 0 at this point. So this will print 0. It will not be affected by this let count equals 1. So let's see the output. Yeah, you see, first one gave us 1 and the other one gave us 0. So interviewers give us questions like this to understand if the candidate is aware of concepts like block scope or shadowing or not. Okay, so the next question is to write a function that would allow you to do this. Okay, so what's going on over here? We are calling this create base function with certain value, and it is returning us a closure called add6. And then we are calling this add6 closure, and whichever value that we pass inside of it, it returns us by adding the value that was written over here. So if we did 10, so 10 plus 6, 16, 21 plus 6, 27. Okay, so how are we going to do that? What we learned up until now, this is obviously going to be a closure which will be returned from this create base function. So let's create this create base function first. So create base, and it's going to take a number. Cool. Now from inside of this we are supposed to return a function, so let's return a function which I'm gonna keep as anonymous function, and this I'm gonna give, let's say, inner num. And so inside of this, what we're supposed to do, we're supposed to add inner num to this num. So we're gonna return inner num plus num. And obviously, since this is a closure, so num will be accessible inside of this function. So let's see if this works or not. Oh, I think I should console log this. Or maybe I think I should console log this and put this inside of here. Yep. Let's see. Okay, we got this output 16 and 27. So what's happening over here is we have taken this create base as 6. and we have created a local scope for both of these function calls. So we just have to do this once, and this will be initialized with a scope where num is 6. Now doesn't matter what we pass inside of over here. If we pass 15 over here, it's still going to add 6 to it, just like that. So what's happening over here is you can create a closure to keep the value passed to a function create base even after the inner function is returned. So if we don't want this value to change, then we can create a closure where this value is always 6. We just have to pass it once and it's going to access the value as only 6. So this is also one of the use case of closures which makes it so powerful. Okay, so this question right here is kind of similar to the previous question, but it's a little add-on to that. How can we use closures to optimize the time of our code? So interviewer has given us this find function. When we call this find function right here, by the way, just ignore this console.time for now. I've just added this to measure how much time does this function call takes. Okay, so first we are calling this find function with this 6 value. Okay, so it takes the 6 value right here and it has the empty array. And what it's doing over here, we have a really long loop which runs 1 million times. And what it's doing over here is it's assigning the value of I into I to each of the index of this array. Okay, that's fine. So this is being done to make this loop really slow. And then we are console logging the index, whatever index that we provide. So if we have provided the 6 index, so we're just supposed to print that. Okay, so let's save this and check this out. Okay, so you can see right here, it gives us this output, but it's taking this 6 millisecond right here, and the other call takes 12 milliseconds. If we put even higher number over here, let's say 50. So it's taking 135 millisecond right here. Sorry, I said 6 earlier, but it's 67 milliseconds for this one. And this is 135 milliseconds for this one. So how can we optimize this by using closures? So just like what we did in our previous, since we are not touching this value anytime, right? This value is the same for each and every time we call this function. So let's create a function right here, an anonymous function, which will take this console log inside of it. And instead of passing this index over there, we're gonna pass this index over here. So let's do this. Let's create const closure, which will have this find right here. So we have just created an inner function closure for us so that this remains the same for every time we call this closure right here. So now I'm going to replace this with this closure, and this is 50 right here. So I'm going to put 50 so we can recognize this. Okay, so let's see what has changed. Okay, there's a huge change right here. So for 6, I think it was 67 earlier, but now it's 0.25 milliseconds. There's a huge time optimization of this code. And for 50, it was, I think, 135 something, but now it's 0.025. So you see how closure has helped us in optimizing the time for our code. So this is the reason why closure is such an important topic and such a favorite topic of interviewers. Okay, so let's move on to our fourth question, which is on block scope and set timeout with closures. So this question is really important, and this question is asked in a lot of companies. I've already discussed this question in my Unacademy interview experience video. So I'm going to go on and play that clip for you right here. So the interviewer provided me with this code snippet, and obviously we're going to run this over here. So he asked me what is going to be the output for this. So let's think about it. Most people will think that since we are console logging over here, we are running a loop over here, for loop, and we are console logging each of these values inside of over here after 1 second each. So most people will think that the output is going to be this 0, 1, 2. Is it? Let's find out. It is 3 times. Let's refresh the page. So 3, 3, and 3 after 1 second each. So why is this happening? This is because of where. So what where does is, we just discussed in our previous question. So where doesn't have a block scoped. Where has a function scoped. So what's happening over here is, first time this runs, where's value is 0. But this is not going to be printed right away, because set timeout only runs after the complete code has ran successfully. Right, so this is not going to run. So we have a reference to that I variable in our memory. So we have a reference over here, let's say. Okay, then again, the I is 1. Then we again have a reference to the I variable, just like that. And then I is 2. Then we again have a reference to I variable. And then the third time, the value of I is 3, but if we obviously we won't go inside of over here since it says that I has to be less than 3. So we're not going to run inside of it. We come out of this loop, and then setTimeout has finished its time, and now our JS engine is going to print all of these values. So last time the JS engine encountered the value of I, it was 3. Now here JS engine is referring to the current value of I. So the current value of I was 3. So it's going to print 3, 3 and 3. Just like that. Now what's the solution for this? You may have guessed it right. The solution for this is using let instead of where. Let's see the output. 0, 1, 2. Yes. So what's happening over here is let is block scoped. So first of all, let's value was 0. So it has the completely different scope. So in this scope, the value of I was 0. So it's going to print it later on. Then again, the second value of I was 1. So again, after the complete code has ran successfully, it's going to look into the scope of that I variable. And when it looks into all the 3 scopes, it's going to find 0, 1 and 2. So this is the logic behind this question. So actually this was the follow-up question that the interviewer asked. I just explained it to you in one go. So these were 2 different questions that the interviewer asked. Interviewer asked first to tell him the output of the first with where, and then he asked me how we can print 0, 1, 2. So then I went on and explained him with let. So this was the question. But few of the interviewers extend this question even more. They're gonna say you're not allowed to use let. You're gonna have to use where instead of let, and you have to print 0, 1, 2. You have to give this output. How are we gonna do that? So this is a task for you all. I'm gonna give you a small hint. It's gonna use closures.
All right, pause. If you're not yet following me on Twitter, go to twitter.com/Piyush_Eon or click the link in the description down below and hit that follow button right now. I'm waiting for you. I'm still waiting. Okay, fine. Let's continue with the video.
Okay, so in the end of that clip, I asked you a question that how will you do this just by using where? How will you print 0, 1, 2, 3 by using where only instead of let? So how will you do that? You're gonna use closures. So we're gonna create a closure over here. Let's say inner. And it's gonna take I as a local variable. And I'm gonna put all of this inside of this closure. And we will call this inner closure and pass the I to it. So what's gonna happen is every time this I is passed to this function, it is not going to reference, just like we discussed, it's not going to reference that particular memory value. It's going to create a whole different memory space for this function right here for every time this loop runs. So we're passing I over here, and now I will be a local variable inside of this function rather than taking it from our outer scope. So let's run this, and yep, you can see we get this output 0, 1, 2. Awesome. So the next question is, how would you use a closure to create a private counter? So what is a private counter? Let me show you. So if we create a function right here called counter, and we don't take anything inside of it, and we have a variable counter equals 0. So I've put underscore over here because this is a convention. When we create private variables, we put underscore before that. You don't have to follow this, but it's a good practice. So how can we create a private counter? So we already know that we can't access this variable outside of this function, right? So how are we going to update it? So I'm going to create a bunch of functions inside of it. First one will be the add, which takes an increment variable. By how much value is this going to be incremented? So this is going to return counter plus increment. So it's going to add this increment to this counter. And you know what? We don't need this return statement. My bad. So we're just going to do this. It's just going to add this increment to counter. Cool. Then we'll have another function which will retrieve the value of counter. Just gonna say return counter equals, and I'm gonna provide the counter just like that. Now we're gonna return both of these functions. So I'm gonna return add and retrieve just like that. Cool. So let's go on and initialize this counter right here. So I'm gonna say const c equals counter. So this has created a new counter, a private counter. So what we can do is we can say c dot add, and we can provide it value, let's say 5. So it's going to add 5 to that counter. And let's say if we provide it value, let's say 10. So after this, the counter should be at 15, right? So let's go on and call retrieve and check. So let's see in our browser. Okay, I think, oh yeah, we're supposed to console log this since it's returning the value. All right, so counter equals 15. So this is what a private counter is. We are not directly manipulating the counter. We are using these functions right here to manipulate the value of this private variable or the private counter. Now there's a similar concept which relates to this one, which is called a module pattern, which we're going to discuss in our next question. So interviewer can ask you this question, that what is a module pattern? So a module pattern looks something like this. So we have a iffy right here, and we have a private function inside of it, and we have a public function which we are returning to the user. So user can make use of this public function, and this public function, we can write a code inside of it which can call this private method right here, or the private methods or private variables of this module right here. So they will not be accessible outside of this module pattern. So private functions are not returned. Not returning these functions makes them inaccessible outside of the module namespace. But our public function can access our private functions, which makes them handy for like helper functions. For example, if we are supposed to make an API call inside of it, but we don't want the user to access it directly, so we can just use our public method to, let's say, manipulate it in some way so that it works exactly as the developer wants it to work. So in these cases, module pattern helps us a lot. So let's say if we go on and console log public, and we put this inside here called private module dot public method, and we called module dot private method. So this will be called, but this will give us error. So let's see. Yep, this is called, and this gives us module dot private method is not a function because it's not going to be returned from that function. Cool. I would highly recommend you to go and read more about module pattern on your own, because this can be a really important question, and sometimes it's also asked in junior interviews, but mostly in the senior developer interviews. Okay, so next question is that interview provided us this function like the video, and inside of it we have this variable view. So view is defined outside. We have declared view variable outside, and we are initializing it inside of our function, and then we are console logging it. So the question is to make this run only once. So if we call this function and again, you're gonna see that we get this output again and again. So what can we do to make this run only once? So obviously we're gonna make use of closures. So we're gonna create a local variable inside of it. Let's let called, it's gonna be 0 by default. And inside of this, I'm gonna create a new function. I'm gonna return a new function. It's going to be an anonymous function, and inside of this I'm going to check if called is equals to 0, then you know what, I'm going to say if called is more than 0, then obviously this is already called. So I'm going to console log already subscribe to Roadside Coder, and I hope you are also subscribed to Roadside Coder. Otherwise, else, if this is not more than 0, then we're gonna take this code and put it right over here. And after this is console log, I'm gonna say called plus plus, so that called is not 0 anymore. And then we will print already subscribed to Roadside Coder. So I think this should work. First time this should print subscribe to Roadside Coder, and then after that it should print already subscribed. Let's see. Oops, my bad. I need to call it first. So I'm gonna say I'm just gonna remove this for now. I'm gonna say is subscribed, and it's gonna take like the video, and now we can call this. So by doing this, what we did is we created a local scope with let called equals 0. And every time we call this, it's gonna reference to the same called variable. So let's call it bunch of times and let's see. So the first time it printed subscribe to roadside coder, and after that it printed already subscribed to roadside coder. Yeah, so this is what we exactly wanted, which will make this run only once. Now this is not the proper implementation of this once, but you can use it if the interviewer asks you to do something like this. But if interviewer asks you to create a more generic function, then how are you going to do that? Let's see. So actually there's a library called Lodash which already has an implementation of this once function. So I'm gonna go on and create the polyfill for this once function right here. Okay, so let's create a more of a generic function. So I'm gonna create a function with the name of once, and it's going to take two things. It's going to take a function and it's going to take a context, local context if there's any context there. Now inside of this, we're going to create a local variable called ran, and I'm just going to declare it like that, which will determine if this function has been ran once or not. And after that, I'm going to create a closure, which is going to be an anonymous function. And inside of this, I'm going to check if there's something inside of the function, then go inside of it, and ran will be function.apply, and I'm going to provide the context if the context is provided. Otherwise, I'm just going to provide the this, that is whatever the context of this function is. I'm just going to point to that one by using this. Don't worry, as I've already mentioned that I'm going to bring a complete video on this implicit and explicit binding, which will cover this variable and call, apply, bind, all of these concepts. So don't worry, that video is coming very soon. So all this apply does is, all you need to understand for now, that it's giving our function a new context and the arguments, if any. So I'm going to pass all of the arguments, and as you know, this arguments will be an array. So I would highly recommend you to go and read about this apply function if you don't understand how this works, because that will be a little out of scope for this video. So all it's doing over here is it's providing it a new context and a bunch of arguments. Let's say if we have 1, 2, 3, it's going to provide it just like that. Now after this runs, it's going to provide the output to this ran variable, and I'm going to put the function to null so that we can not call it again. And after that, we're going to return null. Oops, return ran, just like that. And this is our once function right here. Don't worry, I'm going to run this and again explain you how this exactly works. So let's say I have variable hello, which is a function which console logs hello. So how are we supposed to run this only once? So if I print this multiple times, you're going to see that it runs multiple times. Okay. But when we wrap this inside of this once function that we have created right here, then you're going to see that it runs only once. It's not going to run again and again. Doesn't matter how many times you call it. So what's happening over here is it takes this function over here. Okay, cool. Now inside of this, we have a closure, which will be returned inside of this variable, the reason how we're able to call this. And then we're checking it if the function has some value. Yes, it has this value. Then we are running this function. And after we run this, it's going to have the result inside this ran variable, and function will be null so that we can't run this again. And then we simply return the output of this function. But what if we had some arguments? So let's say if I pass 1, 2. So let's take a, b right here, and I'm gonna print a, b. And check this. Yep, you see, it's gonna run with the provided arguments because we are providing the arguments right here. So this is how once function is supposed to work. Now for our next question, we have to create the polyfill of this Memoise. So what is Memoise? So this question was also asked to me during one of my previous interviews. This question was asked to me during my Cast 24 interview, which I've already discussed in that video. So I'm gonna show you that clip right here.
The next question was on implementing a caching or a Memoise function in JavaScript. So for example, if you are given with this function, which has some expensive calculation inside of it, which when executed every time takes a decent amount of time to run. So if I go on and run this, So I'm going to use console.time to measure how much time did this took to run. And I'm going to run it twice actually with the same parameters. Okay, so if I go to console, you're going to see first time it took 40 milliseconds and second time it was 42 milliseconds. So how do we minimize this time calculation? If the parameters of the function are same, we need to cache the result of the previous function somewhere, right? So that is what we are going to implement. So let's say I'm gonna go over here at the top and I'm gonna have function which I'm gonna say my Memoise, and it's going to take a function which we are supposed to memoize, and we're gonna take a context. You know what, let me remove this context for now. I'm gonna show you how we're gonna use that later. So right now we're just gonna take a function in this Memoise, and first of all let's create a variable for storing our result. So const res equals an empty object. So this will be the place where the result for our previously executed function will store, or the cache for our function, right? Then after this I'm gonna return a function, and inside of this I'm gonna take the arguments from the user after making this a memoized function. Now first of all I'm gonna convert all of these arguments that we get from this function into a string. So I'm gonna say var args cache equals json.stringify, and inside of this I'm going to provide the args. So what's going to happen is this args cache will contain all of these arguments. Now we're going to take this args cache and check if we already got these arguments in our cache or not, and if we already got a result for all of these arguments. So I'm going to go down and say if. I'm going to check inside the res. So res args cache. So if we don't have these arguments inside of our object, then we're gonna calculate the result for that function. Otherwise we're just gonna return what we already have. So return this thing just like this. So we're gonna return all of the result for that object. So for example, if we are providing 5 and 6, so our result object will look like this. So let's say a result of 30, right? So this is how our res object will look like, and if it finds out that it already has those parameters, so it's just gonna return us this value. So let me write the logic for that. So inside of over here I'm just gonna add that inside of our res object. So res args cache will contain the result of the logic for that function. So function.call. And now over here we are going to use that context. So if we are sending any context, I'm just gonna provide it. So obviously this context is going to be optional. So that's why I'm gonna say if this context doesn't exist, just use the current context. And obviously we are going to use these arguments that are being sent to us. So I'm just gonna spread all of these args as well over here. Cool. So I think this looks good to me. Let's go on and use this. So again, I'm gonna show you. Previously it gave us this result both of these times, but now if I go on and memoize this function, so what I'm gonna do, I'm gonna supply this function. You know what, first of all let me change the name of this function. I don't think this fits the appropriate, so this should be clumsy product. That fits better. Yeah, so after this I'm gonna say const memoize clumsy product, and I'm gonna wrap that function. So I'm just gonna take this my memoize and wrap this clumsy product just like this. And now since it's going to return us with a function, as you saw over here, return this function, so we are going to get a function inside of this over here. So I'm just gonna replace this clumsy product with our newly memoized clumsy product. So now let's find out if it worked or not. Yep, awesome. So you see in the first call it gave us 49 milliseconds, and in the second call it was 0.08 milliseconds. Oops, my bad, I made a mistake over here. So the else is not going to be over here. So this is just going to be returned. So it's just gonna check. So this is an optional condition over here. It's gonna check if it doesn't exist inside of this array, then just add it to our result and then return it. Otherwise, if it is inside of our result object, then just return it directly. So now you're gonna see, yep, now we get both of these result over here. Awesome. So this is how you go on and implement a caching or a memoization function in JavaScript. So this is a really important interview question.
Alright, so our next question, which can also be very frequently asked, is the difference between closure and scope. So whenever you create a function within another function, then the inner function is the closure. This closure is usually returned so you can use the outer functions variable at a later time. So this is what a closure is. Whereas a scope in JavaScript defines what variable you have access to. There are two kinds of a scope, as we already discussed, global scope and local scope. And in case of closures, there are global scope, outer scope, and local scope. So yeah, you can give this answer in your interviews and that should be good enough. And these were all of the interview questions related to the closure. I hope you liked this video, so give this video a huge fat thumbs up and subscribe to the channel for more such awesome interview videos. And I've actually returned an article for this video as well, so you can find that article from the link in the description below and get access to the written format for this video. And in our next video, we will discuss currying in JavaScript, which is also part of our functional programming and closures concept.